In this video, we'll look at even and odd functions. First, we'll start with the definition of even functions. There's many ways to write it, but an even function is a function, obviously, that has symmetry. I'm forgetting if there's two m's or one m. There's one t that has symmetry about the y-axis. So if it's symmetrical, if it perfectly flips over the y-axis and makes the exact same shape when you flip it over the y-axis, it's even. Let's do an example. Classic example is the parent function of a parabola, y equals x squared. There are many, many others. This is just one. I'm doing a rough sketch. Even though I'm rough sketching, still label the arrows and the x and y. This is supposed to be the parent function y equals x squared. And hopefully you see, if you took this function and flipped this part over the y-axis and this part over, you get the exact same thing back. It's clearly symmetrical about the y-axis, the parent function of a parabola. Let's take a different example where you get an equation and you want to see, for example, what if we shifted that parabola, let's call it f at x equals, and we shifted it up 5. The question is that function, this parabola shifted up 5, is it still even? And you could sketch it and see that it is. But there's another way to check, and I want to show you how to check algebraically. To see if something is, looking at its equation, to see if it is even, we're going to check and see what happens when you take f at negative x and compare that to f at x. What happens when you take f at negative x and compare that to f at x? So we're actually going to sub it in. What happens when you sub in negative x into this equation? You would get negative x squared plus 5. But you know, I hope, from rules of exponents and multiplying negatives, squaring means we're going to multiply negative x times itself, and a negative times a negative would be a positive. So we would get x squared plus 5. This algebraic method then compares this f at negative x to the original equation. And if they're the same, then the function is even. Look what that means. It means that if you go left, say negative 2, you get the same as if you go right, positive 2. That's just like this one. If you go left, negative 3, and check out the y value, you should get the same thing if you go right 3 and check out the y value. And this is how you check algebraically that this function is even. And indeed it is, because going left any x gives the same y value as going right any x. So I'll write that. Since, upside down therefore is since f at negative x equals f at x, then by definition, therefore, it's even. We've done it. We've shown it. What about odd symmetry? Let's define it first. An odd function, or a function with odd symmetry. An odd function is a function that has 180-degree rotational symmetry about the origin. Okay, fancy words. All it's saying is this: if you rotate it 180 degrees about the center, the origin, you get the same graph back. So again, there are many, many examples of graphs that do that. Classics. Let's just look at one here. For example, don't forget to again to label your arrows on your x and y axis. The classic one, which I hope you know, or you can watch the video on it. This is supposed to be the parent cubic function, y equals x cubed. This is a function clearly not even, right? If you reflect this in the y-axis, you'd get the opposite shape, not even. But can you see, if you put your finger here or you pin it down here and rotated it 180 degrees, you'd have the exact same thing back? That's how you know that this function is odd, that it has rotational symmetry 180 degrees about the origin. So what about a function, and we wanted to check to see if a function, given its equation, if that function is odd. So let's I mean, but I'll come up with an equation. In fact, let's use the same one just to make it clear. Let's check this function. We already know, just by looking at it, you can see this function is odd. But how do you show that using algebra? Well, it's a little bit different here. You're going to have to know what to check for. With even function, we check that f at negative x equals f at x. With an odd function, we want to check, is f at negative x the same as f at x negative? Okay, let me explain what that means. It means if you go negative on x here and get some y value, you should get the exact same thing as if you go positive x, but opposite y value. Let me say that again. A negative x value going left should give you a y value that's the same as going right, but opposite sign. And that's what this is. Let's see what happens when we sub it in. We sub in a negative x here, you'd get negative x cubed. Well, that's the same as cubing the negative, or cubing negative 1, and cubing x. Cubing x is easy, you just get x cubed. What happens when you cube negative 1? You can check on your calculator, but you should know negative times a negative is a positive, times the third negative will make it negative. On this side, we check what happens when you do negative f at x. You get negative f at x, which of course, when you have a negative times a function, it just makes the function negative. In other words, when you sub in a negative x into this equation, you get the same thing as putting a negative in front, and that's the definition of odd. And again, we write, since f at negative x equals negative f at x, therefore, it's odd. So, we've looked at even and odd functions. We know what their definitions are. We could sketch an example. And we know how to check if they're even or odd using function notation.